Hi friends, welcome to Arnav's world. Today is the third episode in science. Today we are going to discuss about chemistry. Again in chemistry, about atoms. So today we are going to talk about atoms, which are the smallest building blocks of everything. But there are some even things smaller than this. An atom is the smallest unit of an ordinary matter that forms a chemical element like ourselves or gold that you may wear right now. An atom comes from the Greek word atomos, meaning uncuttable, because then they thought it was the smallest unit, but there are things smaller than that, so protons must have the uncuttable name, or electrons, those things. Okay, the components of an atom are electrons, which are negatively charged, in a nucleus, which is made of protons, which is positive charged, and neutrons, which is, guess it, mixing those together and to make a not charged particle. That means it has no charge. 99.94% of an atom's mass is the nucleus, and most of the remaining space is, guess it, empty space. Yeah. So, for example, one fun fact. So, if every person was taken and their empty space was gone away, it would be the size of a sand grain. Mind blowing. Okay, now we are going to talk about electrons. Electrons, they are negatively charged. Their mass is 9.11 times 10 to the power of negative 31 kgs. It's too big to say, so ask Google. I won't say. The size is too small to measure. Wow. If an atom has more electrons than its protons, it has an overall negative charge because they are negative charged. If you don't understand. But if there are fewer electrons than its protons, it has an overall positive charge. And are you wondering why there is a VE? Because positive and negative have a VE at the end. Fun fact. These are called as ions. Some examples of ions are H+, O-, yeah, those things, which make up water or anything. The electrons of an atom are attracted to the protons by the electromagnetic force, which is a force just attracting both of them, like magnets, how they attract each other to iron or other magnets. Electrons have properties of both a particle and the wave, so it might go like this or even like this. Just like light, photons are like the same. The size of an electron is too small in an atom. It's the size of sand grain compared to a football stadium. Now I will tell the things that are inside the nucleus. First is the protons. These protons are positively charged and their mass is 1836 times the mass of an electron. That means 1.67 times 10th to the power of negative 27 kilograms. Yeah, those are the same. The number of protons in an atom is called its atomic number. For example, carbon atom's number is 6. That means the number of protons in the carbon atom is also 6. Another example, oxygen atomic number is 8. That means it has 8 protons in the atom, or also known as the oxygen. The protons are composed of 2 up quarks and 1 down quark. If you don't know, quarks are the things that make the neutrons or protons, but not the electrons. Those are kind of related to. If number of protons and electrons are equal, the number is electrically neutral. Yes. Neutrons. These have no electric charge. Its mass is 1800 or 1800 339 times of the mass of an electron. That's the bigger than the protons. These are the heaviest of the three constituent particles. Wow, this is the heaviest. So, but we can still weigh them. Okay, neutrons are composed of one up quark and two down quarks. One up and two down. The isotopes. The number of neutrons defines the isotope of the element. So, the normal carbon atom is C12, which consists of 6 proteins and 6 neutrons. But you may ask, why is it 12? Now I will explain another thing, which is atomic mass number. The sum of the numbers of proteins and neutrons is called the atomic mass. Example O16. Protons and neutrons. Example O16, which is 8 protons and 8 neutrons. Yeah. So that's why this is C12, which is the sum of both 6 and 6, 12, if you know basic maths. The next is C14, which is consisting of 6 protons and 8 neutrons, which makes it radioactive. That means it will throw out some of the neutrons, the remaining neutrons, which doesn't make it equal to the number of protons. That causes radioactive decay, that means taking out the neutrons which are excessive and throwing out the whole atom. Another example is hydrogen, which has 1 proton and no neutron, and deuterium, which is an isotope of hydrogen, which has 1 proton and 1 neutron. And another isotope of hydrogen, tritium, which has 1 proton and 2 neutrons. If one isotope has a more difference between the neutrons and protons, that means it is more radioactive. Yeah, like uranium, which is not an isotope, but still it's radioactive. Yeah. Now I'll show you the atom. There's some things about the atom as well. Atoms are very, very small, and they are the building blocks of everything in the world. But there are still things smaller than them. And light is not made of atoms. It's made of photons, which are the size smaller than electrons or the same size, similar to them. Yeah. And also quarks are like electrons. They are. This is a proton inside an atom. A neutron here and an electron here around the atom that goes. So here what I draw is the deuterium, for example, to just show the neutron. But if we use hydrogen, there would be no neutron. Wow. For example, this is a deuterium. So actually this is not for scale. For scale. Actually, if an atom is the size of a football stadium, the nucleus inside would be just one marble, which would not be so big. It would be smaller than that. And the electrons around it would be the small sand grains in the sides. Now I will tell some facts about atoms. The first fact, to measure atomic sizes, we used an angstrom, which is powered by -10 meters. 10, both tens. So 50 million atoms of solid matter line up into a row would just measure 1 centimeter. Smaller than this. The number of protons and neutrons in the atomic nucleus can be modified. This can require a very high energy. Nuclear fusion. We said that in the sun video. Multiple atomic particles join to form a heavier nucleus, just like in the sun's core, where it is so dense they just have no space and just mix together. The next is nuclear fission, which is the exact opposite of nuclear fusion. Here nucleus splits into two smaller nuclei. It usually happens to radioactive decay. That means when the neutron goes away, it becomes another atom or isotope. Yeah. So that's for today. Bye.